Welcome back. Let's learn how to solve basic general inequalities. Alright, so in the previous two lessons, we learned how to solve inequalities that involved using the addition properties of inequalities or the multiplication properties of inequalities. But oftentimes we will need to apply both of those properties in order to solve an inequality. And then on top of that, just like with equations, sometimes inequalities will involve parentheses that we have to deal with in order to solve. For example, consider these inequalities. All three of these inequalities are a little more complicated than anything that we have solved in previous videos. They will require the use of both the addition and multiplication properties of inequalities, and some of them involve working with parentheses. And so these are what I'm referring to when I'm talking about basic general inequalities. In a lot of ways, these are very similar to the inequalities we have solved before. They each still involve only one kind of variable, and that variable is to the first power. It's not being squared or anything like that. It's just that solving these inequalities will involve more than just one or two steps. Okay, and so we are going to solve these three inequalities in this video, but before we work on that, remember, the goal when solving inequalities is to get the variable by itself or isolate the variable. And so in each case, you will have to make use of different properties of inequalities in order to get them in that form, whether it's the addition properties or multiplication properties, or in the case of these last two, you need to deal with these parentheses. And just like with equations, you're going to want to remove those parentheses before you try to solve for the variable. And to do that, you need to make use of the distributive property. Okay, so remember that if you have a value of a multiplied by an expression contained within parentheses, such as b plus c, that you can distribute a through that quantity by multiplying it by each piece and adding it together, right? You multiply a by b to get ab, and then you multiply a by c to get ac. All right, so that's what you want to keep in mind for solving these basic general inequalities. So really there's nothing new here. All the skills and techniques for solving these inequalities you have learned before individually, but now we're going to put everything together to help us solve more complicated inequalities. And so let's get started. Let's take a look at our first example, or our first inequality, which is this one right here. In this example, we want to solve the inequality and then graph the solution set on a number line. All right, and our inequality is 3x minus 4 is less than 5x plus 2. Okay, so what I noticed first about this inequality is that there are multiple instances of the variable of x. Okay, we want to isolate and solve for that variable in order to solve the inequality. So we want to try to combine those terms so that we only have one variable to solve for. And we can do that by making use of the addition property of inequalities, which allows us to add or subtract the same term from both sides of an inequality, and the solution set to the inequality will remain unchanged. And so in this case, what I will do is get rid of this 5x on this side of the inequality by subtracting it from both sides, right? If we subtract 5x from both sides, we are allowed to do that. That will not change the solution to the inequality, but by doing that, this 5x and this negative 5x will combine to be 0, just leaving you with 2 on this side of the inequality. All right, and so simplifying this side, 3x and negative 5x are like terms that we can combine. They have the same variable part, so just add their coefficients. 3 and negative 5 combine to be negative 2, so we get negative 2x minus 4 is less than 2. And now we just have one instance of that variable of x, which means that we are now one step closer to solving this inequality. But we're not quite done yet. We do need to isolate that variable of x, which means our next step is to get rid of this constant term of negative 4, right? We want that variable term by itself so that we can solve for x. So let's get rid of this negative 4 by adding 4 to both sides of the inequality, right? If you add 4 to both sides, which you can do, because we're adding the same value to both sides of the inequality, that will not change the solution set. But by doing that, negative 4 and positive 4 combine to be 0, just leaving you with a negative 2x is less than 2 plus 4, which is 6. So we get negative 2x is less than 6. All right, and now we're almost done. The last thing we need to do to isolate and solve for the variable of x here is get rid of its coefficient of negative 2. And we can do that with the help of the multiplication property of inequalities, which allows us to multiply or divide both sides of an inequality by the same number without changing the solution set of the inequality. But there is one caveat to that. If the number that you're going to multiply or divide both sides of the inequality by is a negative number, you have to remember to flip the inequality sign. And that is the case here. The coefficient of x is -2, so to get rid of that coefficient, we would have to divide both sides of the inequality by -2, which is a negative number. And when you multiply or divide both sides of an inequality by a negative number, you must flip the inequality sign in order for the inequality to still be true. Now, if you haven't seen that before, or you don't know why that is the case, feel free to go back to my lesson on the multiplication properties for inequalities because I do explain it there. But for this video, I am going to assume that you have seen it before. I just simply want to remind you of that rule here because it is necessary in order to get the correct answer for the solution set of this inequality. Alright, so continuing my work up here, if you divide -2x by -2, those -2's cancel out because anything divided by itself is 1. So you have 1 times x, which is just x. So we get x. But is it less than 6 divided by -2? No, it will be greater than because we did divide both sides by a negative number. So we have to flip that inequality sign from being a less than sign to being a greater than sign. And x will be greater than 6 divided by -2, which is -3. And so x greater than -3 is the solution to this inequality. But now let's graph it on a number line. I'll draw mine like this. I'll let the center be the value of 0, but then x can be any value greater than -3. And so if this is -1, -2, -3, we would then draw an open circle at -3 because we're not including that value, right? X is not greater than or equal to -3. It's just greater than -3. So we draw an open circle at -3 to indicate that it's not included. If it was, we would fill in that circle. But then all the values of x greater than -3 would be to the right of -3 on the number line. So I'll draw an arrow to the right. And there you have it. That is the solution to this inequality, and we have graphed it on a number line to see visually what values of x are included in the solution set. Okay, let's move on to our next example. Hey, real quick, before we get to the next part of this lesson, if you find my videos here at JK Math to be helpful, then I'd like to invite you to join my membership site JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you'd get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. Okay, so if you're interested in becoming a member, feel free to check that out, as it's a great way to support me in the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the lesson. Next up, we want to solve this inequality and graph the solution set on a number line. And we're given -2 times the quantity x minus 7 is greater than 3 minus 4 times the quantity of 2x minus 3. Okay, so the first thing I notice about this inequality is that it involves parentheses. As soon as you see parentheses in your inequality, you want to try to remove them, because currently we really can't solve for x when it's inside of those parentheses. We have to get it out by removing the parentheses using the distributive property. So let's do that here. Starting on this side of the inequality, we need to distribute -2 into these parentheses, so we need to multiply -2 by x and multiply -2 by -7. Doing that, we will get -2x plus 14. Right? -2 times x is -2x, and -2 times -7 is positive 14. So that will be greater than 3 minus 4 times these two terms in these parentheses. And so what I'm going to do is distribute -4 through those parentheses by multiplying it by both of those terms. So we'll multiply -4 by 2x and multiply -4 by -3. Doing that, we get -8x plus 12, right? -4 times 2x will give you negative 8x because you want to multiply negative 4 by that coefficient of x, and negative 4 times 2 is negative 8, but then you keep that x part, and then negative 4 times the negative 3 is positive 12. And so now we have successfully removed the parentheses in this inequality. Now we just have different variable and constant terms to work with. And the next thing that I notice here is that we do have two like terms on this side of the inequality. 3 and 12 are both constants that we can combine. 3 plus 12 is 15. So we'll have negative 2x plus 14 is greater than 15 minus 8x. Okay, and now the next thing we want to do is combine our variable terms, right? We have two terms involving x, but in order to solve for x or isolate it, we need just one variable term involving x. So we have to get rid of one of these from one side of the inequality. And I'm going to choose to get rid of negative 8x. Let's add 8x to both sides of the inequality. By doing that, this negative 8x will cancel out with this positive 8x. They will combine to be 0. So cross those out, and then simplifying on this side, negative 2x and 8x combined will be 6x. Right? These are like terms with the same variable part, so add their coefficients. Negative 2 plus 8 is positive 6. So we have 6x plus 14 is greater than 15. And now we want to get this variable term by itself, so we have to get rid of this constant term, which we can do by subtracting 14 from both sides of the inequality. So that's what I'm going to do next. I'll subtract 14 from both sides, and so 14 minus 14 becomes 0. So we're just left with 6x is greater than 15 minus 14, which is 1. Okay, and so our final step here to solve for x is to get rid of this coefficient of 6. So what we want to do here is divide both sides of the inequality by positive 6. So continuing our work over here, we currently have 6x is greater than 1, but if we divide both sides by 6, we can solve for x. These 6's will cancel out because anything divided by itself is 1, so we have 1 times x, which will be greater than 1 divided by 6, which I'll just keep as a fraction. We'll have x is greater than 1/6. And that would be the solution set to this inequality. And do notice that unlike our first example, we did not have to flip the inequality sign when dividing by 6 because 6 was a positive number. All right, if we had to divide by negative 6 or some other negative number, then we would have had to flip the inequality sign, but we did not have to do that here, so it remained the same. Okay, but we still have to graph this solution set. So let's draw a number line. Once again, I will let the middle be 0, and positive 1/6 is just a little bit bigger than 0. So I'll put it right here on the number line. That will represent 1/6, but then that value is not being included in the solution set, right? X is just greater than 1/6, not greater than or equal to. So I'll draw an open circle at that value, and then draw an arrow in the direction of the other values included in the solution set, which are any values of x greater than 1/6. And values greater than 1/6 are to the right of that number on the number line. All right, so I will draw an arrow in that direction, and we're good to go. We have now solved this inequality and graphed its solution set on a number line. Let's take a look at one more inequality for this video. Alright, so for our last example, we once again want to solve the inequality and graph the solution set on a number line. And we're given this inequality of 4 plus 2 times the quantity 3 minus 2y, and that is greater than or equal to 4 times this quantity of 3y minus 5, and then we were subtracting 6y. Okay, so this time around, the variable that we're solving for is y, and it is located at 3 different spots within the inequality, so we have quite a bit of work to do here because we will need to isolate that variable of y. Okay, and so at first, this can look pretty intimidating, but just remember to do one step at a time. And the first thing that you should see here that you want to work on are those parentheses. When you see parentheses in the inequality, you want to remove them. You want to make use of the distributive property. So that's what I'm going to do here. Starting on this side of the inequality, I'm going to distribute 2 through these parentheses. So I will multiply 2 by 3 and multiply 2 by negative 2y. So let's do that. We still have this 4, but then we'll have 4 plus 2 times 3, which is 6, and then 2 times negative 2y, which gives us negative 4y. right? If you multiply 2 by the coefficient of that variable term, 2 times negative 2 is negative 4, so you have negative 4 times y. All right, and then that will be greater than or equal to 4 distributed through these parentheses. So we need to multiply 4 by 3y and multiply it by negative 5. Starting with 4 times 3y, you want to multiply 4 by the coefficient of y. So 4 times 3 is 12. Keeping the y, you get 12y. And then 4 times negative 5 is negative 20. So you have 12y minus 20, but then don't forget about this negative 6y. So we have minus 6y. Okay, so now we've gotten rid of the parentheses. And so before we go any further, let's check to see if there are any like terms that we can combine in order to make our inequality even simpler. And on this side of the inequality, we have two constant terms that can be combined. 4 plus 6 is 10, so we'll have 10 minus 4y is greater than or equal to these three terms, but we can combine two of them as well. 12y and negative 6y are like terms. They have the same variable part of y. So we can add their coefficients, 12 and negative 6, combined to be positive 6. So we'll get 6y minus 20. Okay, once again, 12y and negative 6y combine to be 6y. That's where that comes from. All right, but now notice that we still have two terms that involve the variable of y. So we want to try to combine them. We just want one term involving y. And so what I'm going to do here is subtract 6y from both sides of the inequality. So if we do that here, if we subtract 6y from both sides, positive 6y minus 6y will cancel out with each other. They will combine to be 0. And then negative 4y minus 6y, those are like terms, so combine their coefficients. Negative 4 minus 6 will give you negative 10. So we have 10 minus 10y is greater than or equal to negative 20. Okay, and so now we just have one term involving the variable of y. So we're getting very close to being able to solve for it. But before we can, we have to get rid of this constant term on this side of the equation. We need to have that variable term by itself. So let's get rid of 10 by subtracting 10 from both sides of the inequality. So 10 and negative 10 cancel out to become 0, leaving us with a negative 10y is greater than or equal to negative 20 minus 10, which will be negative 30. Okay, and so we're almost done. There's one more step we need to take care of here, and that is to eliminate the coefficient of this variable term. We need to divide both sides by negative 10 so that we just have y being compared to some other number. And so let's isolate y by dividing both sides of the inequality by negative 10. And so continuing my work over here, we currently have negative 10y greater than or equal to negative 30, but then dividing both sides by negative 10, these negative 10s will cancel out, just leaving us with y, but notice that we did divide both sides by a negative number, so you have to remember to flip the inequality sign, okay? Again, whenever you multiply or divide both sides of an inequality by a negative number, you have to remember to flip that inequality sign. All right, so this becomes y less than or equal to negative 30 divided by negative 10, which will be positive 3. Right, the negatives will cancel out because a negative number divided by a negative number will be a positive number, and 30 divided by 10 is 3. So we get positive 3, meaning that our solution set is y less than or equal to 3. But now let's graph that. Let's put it on a number line. Once again, I like to put 0 at the center, and then we are comparing y to positive 3. So if this is positive 1, 2, and 3, y can be less than or equal to 3, so 3 is included in that solution set, so draw a closed circle at 3, and then you want to point an arrow in the direction of values less than 3. And values less than 3 will be to the left of 3 on the number line. So I'll draw an arrow in that direction. That is the solution set for this inequality, and this would be its graph on a number line. Okay, and so this was the last example for this lesson, but if you do want to get some more practice solving these basic general inequalities, feel free to check out my examples video for this topic that I'll have linked here on the screen. If you have any questions, please let me know in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.